Welcome to our channel Maritime TV, and today our topic is about centrifugal pumps. We will see complete engineering guide, how it works, components, applications, maintenance. This is the number one most used pump. Also 35% it is used in industries. Also this pump, it has more than 100 applications. As you see here, this is a cross section of a centrifugal pump. So what is a centrifugal pump? A centrifugal pump converts the mechanical rotation of an impeller into kinetic energy, then into pressure, moving fluid from suction to discharge. These are the key points. Converts mechanical energy to fluid pressure energy. Operates through centrifugal force or rotational force. It handles water, chemicals, slurries, and more. This pump is most widely used pump type in industry globally. It is a simple design. It has few moving parts, so high reliability. Let's see this pump assembly, showing labeled components. Number one, have suction inlets. It's a suction inlet where liquid enters to the pump. We have impeller, which move fluid outward to the discharge. So we have discharge line, this one. Here I have mechanical seal to prevent leakage for fluid. Also, we have this casing bearing coupled housing. It's for bearing housing. Bearing housing, so I have a casing volute. Casing volute, this one. So we have coupling, this one, of coupling, which connect motor shaft to the pump. Also, we have motor, which provide power to run the pump. Let's see principle of operation. First, the fluid enters. A liquid is drawn into the pump through the suction inlets, eye of the impeller, at low pressure. Then, impeller spins. The motor-driven impeller rotates at high speed, continuously imparting kinetic energy to the fluid. Our centrifugal force. Then, centrifugal force throws fluid radial outward from the impeller hub towards the outer diameter. Pressure builds. The volute or diffuser converts high velocity into pressure. Fluid exits at high pressure through discharge. So you have key equation, you can see here. So let's see key engineering terminologies mostly used in centrifugal pump. We have head. What is head? This is a height equivalent to which a pump can raise a fluid. It is expressed in meters. As total head is equal to static plus friction plus velocity head. Also, we have NPSH. This is a net velocity, net positive suction head. This is the minimum absolute pressure at pump inlets or pump suction to prevent cavitation. Normal NPSH available should be greater than or equal to NPSH required so as to prevent cavitation. If this is reverse, means the pump will have cavitation. Also, we have this term cavitation. What is cavitation? This is the vapor bubble formation when the pressure falls below fluid vapor pressure, causes severe erosion and noise. Also, we have a flow rate. What is the flow rate? It's a volume of fluid delivered by unit time, measured in meter cubic per hour or GPM, primary pump saving parameters. Also, we have efficiency. This is the ratio of hydraulic power output to shaft input power. Also, we have BEP. This is the best efficiency point, the flow rate at which the pump achieves maximum efficiency. is operate within 80% to 110% of PEP. Let's see main components and overview. Every centrifugal pump consists of these critical parts. Number one, impeller, volute casing, drive shaft, bearings, mechanical seal, motor or driver, wirings, and suction and discharge nozzles. Okay, don't forget to subscribe to our channel to get more notifications and more learnings. Let's see components. One by one, detailed look at each part, function, design, and materials. Number one is impeller. This is the heart of the centrifugal pump. The impeller is the only rotating hydraulic component. So in centrifugal pump, the only rotating hydraulic component is impeller. Fans accelerate fluid outward through centrifugal force. Design determines head, flow, efficiency, and net positive suction head. We have different types of impellers. We have open impeller, which is mainly for solid and slurries. This is easy to clean and low probe, but is low efficient and wear sensitive. Also, we have semi-open. It's used for general purpose. It has good balance and adjustable. Moderate efficiency. Also have closed the impeller. It's for clean fluids. It's highest efficient, stable. It cannot handle solids. As you see here, it's diagrams. It's open impeller, semi-open, and this is closed. Okay, also we have casing and volute. The structural housing that direct fluid from impeller to discharge. As you see, the impeller gives kinetic energy to the fluid. So the casing directs that fluid from the impeller to the discharge. What is the primary function of this? It encloses the impeller, converts high velocity fluid into pressure, and it directs flow to the discharge nozzle safely. Let's see materials mainly use the casting iron for waters, stainless steel for chemicals, bronze for seawater, rubber lined for abrasive slurries, plastic for corrosive. Also we have volute design. How volute is designed? It is a spiral shaped passage gradually increased in cross-section area, continuously decreasing velocity and building pressure. Okay, so this is one of the most features to identify the centrifugal pump is this shape, spiral shaped. And this shape is because the increase in its cross-section area, continuously decreasing velocity and building pressure. We have diffuser variants. Some pumps use a diffuser with fixed events instead of volutes, giving higher efficiency at a fixed design point. Let's see shaft, bearings, and couplings. We have drive shafts. This transmits torque from motor to impeller. Must resist bending, torsion, and axial thrust. This material mainly alloy or stainless steel. Diameter designed to limit deflection to 0.05 millimeter maximum. As you see, this diagram, this is our shaft. So you have radial bearings. These support shaft weights and radial loads. They prevent lateral deflection. Deep groove ball bearing are standard. Grease or oil lubricated with defined maintenance intervals. Also, you have thrust bearing. These counteract axial forces from pressure differential across the impeller. Angular contact ball bearings or cylindrical roller for high loads. Critical for pump longevity. Also, you have flexible coupling. This connects motor shaft to pump shaft. Accommodates small misalignment. Spacer couplings allow steel removal without disturbing motor. Must be laser aligned. Also, you have a mechanical seal. Its function is to prevent leakage between the rotating shaft and the stationary casing without stopping rotation. So this prevents leakage between rotating shaft and the stationary casing without stopping rotation. We have stationary ring. Fixed pump casing provides flat left seal face material with silicone, tungsten carbide, or carbon. Also, this half spring mechanism provides closing force, keeping faces together. Single or multiple springs must overcome fluid, film, pressure to seal. Also, you have rotating ring mounted on the shaft. Rotates against the stationary ring. The spring loaded to maintain contact with fluid in lubrication. Also, you have secondary seals. These are O-rings or bellows prevent leakage behind the primary faces. EPDM, tone, or BTFE, depending on fluid compatibility. Okay, don't forget to subscribe to our channel. Okay, now let's see different types of centrifugal pumps. We have single stage. This is the most common. These have one impeller. Low, medium head. Simple, reliable, low cost. Mainly application water supply, irrigation, and general services. Also, we have multi-stage. This is a high pressure. Multiple impellers in series, each at head. Boiler feed, desalination, high-rise buildings. These are some applications. Also, we have axial flow. This is for high flow. Propeller type impeller, very high flow, low head. Flood control, irrigation, storm waters. These are some of applications. Also, we have a mixed flow. It's a hybrid centrifugal plus axial. So this provide medium head and flow. Mainly used in drainage, cooling water, and flood control. Also, we have self-priming. This is the intermittent. It primes automatically after losing suction. Construction, dewatering, and tank transfer. Also have submersible, submerged. Motor and pump both submerged. No priming needed. Mainly used in sewage, groundwater wells, and some drainage. Let's see performance curves. This is the pump performance curves. We have different curves here. This pump HQ curves. It's one. System curve. Have efficiency curve. So we have best efficiency point. It's one BEP. What is HQ curve? It's pump head versus flow. This pump head versus flow. As flow increase, head decrease. As flow increase, head decrease. Define the pump's hydraulic capability. Also have system curve. This is the system resistance versus flow. This parabolic shape operating point equal to intersection with HQ curve. Also, we have efficiency curve with efficiency peaks at BEP operating away from BEP, reduce efficiency and shorten pump life. Always operate near BEP for maximum efficiency and life. Let's see real-world applications of centrifugal pumps. Number one, we have water and wastewater. Municipal water supply filtration, distribution, and sewage treatment, oil and gas, have chemical and pharma, we have agriculture, power and HVAC, marine and offshore. Okay, don't forget to subscribe to this channel. Now let's see the silent pump killer. Okay, cavitation. Cavitation, by definition, this is a phenomenon which occurs when local pressure drops below the fluid's vapor pressure. Liquids turn to vapor bubbles. When these bubbles enter high pressure zone, they implode, releasing forecast shock waves that erode metal surface. So, this is normal operation, showing the flow of fluid in a pump. But this is cavitation to show bubbles formed. So pressure drop below vapor points, it will cause bubbles formation. What are the symptoms for cavitation? You will see cracking or rotting noise. Also vibration. Also head and flow drop. Also the impeller heating and seal failure. Now let's see maintenance schedule of centrifugal pump. Daily maintenance is the pressure gauge, checking pressure gauge, flow monitoring, leak inspection, temperature check, and vibration feel. Also, we have weekly. This mechanical seal inspection, oil level check, strainer cleaning, also performance logging. Also, we have monthly. So bearing, lubrication, coupling alignment, shaft steel check, also motor thermal imaging. This annual full overhaul, Impeller measurements, seal replacement, vibration analysis, and efficiency tests. Okay, so this is a summer. So daily check pressure, monitor vibration, inspect for leaks, record temperature. Weekly, inspect mechanical seal, check lubrication, clean inlet strainer, also log performance. Monthly, have grease bearings, check coupling, inspect shaft seal, motor installation. Per year, we have full overhaul, impeller gear, replace mechanical seal, and vibration analysis. Here we have pump selection guide. The critical parameters to evaluate before selecting a centrifugal pump. Number one is flow rate. So, required volume, time in meter, cubic per hour, or GPM. Set impeller diameter and rotation speed. It's impact on selection. Also, total head, the static bridge, static head, plus friction head, plus velocity head. Determines pump population class and stage. Also have fluid properties. We have NPSH available. We have efficiency point. We have drive motor kilowatts. Let's see troubleshooting guide. If no flow or flow is low, this has causes. Closed valve, maybe suction valve closed or discharge valve closed. Airlock on the suction side, one impeller, wrong rotation direction. How to fix? Open the valves, prime the pump, check rotation direction, also inspect impeller. Also, if you feel excessive vibration occurs, this may be causes shaft misalignment, imbalance, cavitation, or worn bearings. How to fix? Realign coupling, balance impeller, also check NPSH, and replace bearings. Also, when motor overheating, what causes? Maybe overloading, low voltage, operating far from BEP, or block D cooling. How to fix this? Check power supply, verify operating point, clean motor cooling. What if mechanical seal leak? Causes may be worn seal faces, incorrect installation, and abrasive particles. How to fix: must replace mechanical seal assembly, flush with clean liquid, check alignment. How about unusual noises? Causes can be cavitation, recirculation, bearing failure, solids in fluid. To fix this, you must increase suction head, check strainer, also lubricate or replace bearing. These are key takeaways. Centrifugal pumps convert mechanical rotation into fluid pressure through an impeller. Mechanical rotation into fluid pressure through impeller. Core components include impeller, volute casing, shaft, bearings, mechanical steel, and motor. Always operate near BEP or to maximize efficiency, reduce energy cost, and extend pump life. Prevent cavitation by ensuring NPSH available, always exceeds NPSH required. Implement regular maintenance as a daily, weekly, monthly, and annual to prevent costly failures. Select the right pump type and material based on flow, head, fluid, and site conditions. Monitor vibration, temperature, and pressure readings as air warning indicators. Thank you for watching. Now, you must centrifugal pump from first principle to maintenance. Don't forget to like, subscribe, and comment.